In May of 2007, Experian Gallup Personal Credit Index poll of 1,008 U.S. adults aged 18 over, 8% of respondents said they were very uncomfortable with their ability to make their monthly payment on their current debt during the next 3 months. A more detailed survey surveyed 1,288 results, reporting similar overall results and also noting differences among the 4 age groups. Do you expect the 95% confidence interval for the true proportion of all 18 to 29-year-olds who are worried to be wider or narrower than the 95% confidence interval of the true proportion of all U.S. consumers? So remember that when we're just looking at, they have 1,288 adults. If they combine all that, then your sample size is 1,288, which is going to make your standard deviation really small, which makes your margin of error smaller. If I cut that and talk about only the 18 to 29-year-olds, my sample size is smaller, right? And therefore my standard deviation is larger. Because remember our formula, P hat, Q hat over N, right? If N is larger, the standard deviation is smaller because it's on the denominator, right? We're dividing by a number. When we divide by a bigger number, then the overall result is smaller, correct? And therefore the margin of error is smaller. And the interval is narrower. If N is smaller, the standard deviation is larger. And therefore the margin of error is larger and the interval is wider. So we expect the interval for 18 to 29-year-olds to be wider than the interval for all consumers. Okay, because if the sample size is smaller, your interval is going to be wider. Do you expect the second poll's overall margin of error to be larger or smaller than the Experian Gallup poll? Well, again, you had 108 versus 1,288. So the poll with 1,288 is going to be narrower than the original because the sample size is larger. Even if it's only a little bit larger, it's still going to be narrower. Okay, so the second poll will have a smaller margin of error because N is larger. Okay, number 27, wildlife biologists inspect 153 deer, that's your N, taken by hunters and find 32 of them are carrying ticks. So P hat is 32 over 153. We have to convert that to a percentage, a proportion. We can't put 32 into our equation, and a lot of you did that on the quiz. You put 12 into the z-score equation instead of calculating the proportion. Okay, so that was a big spot, and I think I can give those back today. So our p hat is 0.209. Create the confidence interval for the percentage of deer that may carry such ticks. So the first step is to check my conditions. Before I do any calculations, I have to make sure that it's okay to use these calculations. So the sample is not random, but the sample is probably representative. Of the deer? Yes.
A deer having the Lyme disease, like it doesn't correlate to another deer having Lyme disease?
Well, and it's even more so like the they're only looking at the deer that got hunted. And so is there something possibly different about the deer that got hunted from the deer that do not get hunted? I mean, are they smarter? Do they avoid the bushes with ticks in them? Like, we don't really know, right? So we're going to say it's representative, and we can say proceed with caution because we don't necessarily know for sure if it is representative. But so that's kind of how we get around that. We can say, well, if it's not representative, we're going to proceed with caution. And maybe we can't generalize to all deer everywhere. Maybe we can generalize to the deer in this area. Maybe we can generalize to deer that are actually taken by hunters and not the ones that aren't taken by hunters.
So it can be representative, but that doesn't mean we can like generalize it to like all.
Right. If it's not representative, then we can't really generalize our findings to every deer out there. Okay, yeah. I believe so.
So if they're deer stay together.
Right.
So if they're getting, wouldn't that
Hunted.
wouldn't that like one deer having ticks and the other having ticks
True.
be independent because they're
So it would maybe not be independent because they're hanging out.
they hang out and stuff.
Right. They're hanging out. They're getting ticks from each other. So, yeah, definitely, there's definitely all those things we can think about, and that causes us to need to proceed with caution in what kind of conclusions we want to make. Okay? So, we'll say proceed with caution. They may not be representative. What? So we're going to say that 153 is less than 10% of all deer. I think that's a safe thing to say. And then 32 is greater than or equal to 10. And 121 is greater than or equal to 10. Where did I get those numbers? If I had 32 successes, right, out of 153, subtract that, and that gives me how many failures, right? I don't need to take 0.209 and multiply it by 153. It's going to give me 32-ish, right? And so since conditions are met, a normal model is appropriate. I will proceed with caution for a 1 prop z interval. Two is my mechanics. The normal model is the fact that I can use a z star to estimate how wide that interval is going to be. Later on, there's going to be a t model that we use, and we're going to get a different t star for that. And then there's a chi-squared model, so we have to determine which model we're going to use. And it's very clear proportions is the z, the normal model, means is going to be t, and then the categorical is chi-squared. So 0.209 plus or minus, what is my z star for 90%? 1.645. I think I saw somebody's homework and you wrote z star 90% 1.645, but in your calculation you wrote 1.96. So try to make sure you're using the right one. 0.791. Is that right? Okay, so 0.209 times 0.791 divided by 153 square root. Ugh. Normally I don't do the whole thing. I did this in pieces. Remember that if it asks you for margin of error, that's this number, 0.0541, right? This part is your margin of error. And then you add and subtract it to get your interval. So 0.209 plus so 0.2631 and 0.1549. So that's my interval. Part 3 says, or no, part 3 is interpret. I am 90% confident the true proportion of deer with dicks is between 0.1549 and 0.2631. That is interpreting your interval. So this is interpret the interval. Now, if it says interpret what 90% confidence means, and it usually puts that in parentheses, quotations, interpret what 90% confidence means, that's the in repeated sampling %, of constructed intervals you will have to do this on the quiz tomorrow. Will capture the true proportion of deer with ticks. Okay, so that's interpret what 90% confidence means. In repeated sampling, 90% of the constructed intervals will capture that true proportion of deer with ticks.
So we need the part in blue as well as the...
No, this is a separate question.
Oh, okay.
So this will be asked separately. Okay. The interpreting your interval is part of those three. Now, sometimes it does delineate. It'll be like, check your conditions, calculate the interval, interpret the interval. But that's steps 1, 2, and 3. This is kind of like an extra question. Okay. Now, that does not mean there's a 90% chance that your interval contains the true value. Your interval either has it or it doesn't. There's no probability established with that. And most of the time, you'll never know. Okay? We know that 90% of intervals will capture it, but we don't know, we can't calculate the probability that your interval is actually correct. Okay? It's either in it or it's not. There's no probability associated with whether or not it's actually in that interval. It's just that we're 95% confident that it's in that interval. There's no probability associated with that. Okay? Now, part B says if scientists want to cut the margin of error in half, how many deer must they inspect? Well, my margin of error calculation, this is important because this question comes up a lot. If I want to cut this in half, I need to multiply my n by 4. 4 by 4. Where does n lie in this equation? N is underneath what? Square root, right? The sample size is under the square root. And so if I multiply this sample size by 4, what happens when that 4 comes out of the square root? It's like dividing by 2, right? So that's why we have to multiply it by 4. The sample size has to increase by 4 in order to cut the margin of error in half. If I wanted to cut it by 1/3, what do I have to multiply n by? Yes. Okay, because sample size is in the denominator under the square root. So it doesn't have like if I double it, it's going to cut it in half. If I quadruple it, because it's under the square root, it'll cut the margin of error in half. If I multiply it by 9, it'll cut it by 1/3. If I multiply it by 16, it'll cut it by 1/4, right? So if I want it 1/2, then you have to square that. If I want it 1/5, I'm going to multiply by 25, okay? And then we already talked about what concerns do we have, that it may not be representative. In that case, we wouldn't be able to really say that this is what we believe about all deer. Maybe just the deer that get hunted, right? And